Imagine you're slowly falling through clouds right now. Not quite falling, not floating, standing, sort of suspended in the densest atmosphere you've ever felt. While feeling a strong gravity pull you down, making you much heavier than here on Earth. The atmosphere pushes against you like deep water. The air isn't empty here. It's substance. It's roaring. Not like wind on Earth, like an ocean of gas moving past you at hundreds of miles per hour. The loudest, most terrifying sounds you've ever heard. The bass tears through you. You hear an explosion that sounds like a hydrogen bomb. A flash screen. Far below you, lightning the wrong color illuminates the underside of a cloud bank. A moment later, a chunk of slushy ice the size of a softball tumbles past you. You look up, there's just haze. Endless, swirling haze in oranges and browns and pale yellows, with deep red bleeding through somewhere in the distance. You can't see the sun clearly. It's smeared, diffused through layers of cloud thicker than anything Earth has ever produced. This place is real. It exists. We actually sent something there. December 7th, 1995, NASA's Galileo probe plunged into Jupiter's atmosphere at 106,000 miles per hour. It survived deceleration forces 230 times Earth gravity. It survived heat twice as hot as the surface of the sun on the way in. It transmitted data for 57 minutes, an hour basically, before the planet killed it. It descended 160 kilometers, about 100 miles, and it never hit a surface, because Jupiter doesn't have one. It died crushed and cooked at 22 bars of pressure and 152 degrees Celsius. We knew it would. We sent it anyway. So why send a probe to die in a place we can't visit, can't land on, can't really even understand? Because Jupiter is a failed star, not metaphorically, literally. It's made of the same primordial stuff as the Sun, mostly hydrogen and helium. If it had been about 80 times more massive, it would have ignited fusion. We'd have two suns. Jupiter is what happens when a star almost forms, but doesn't. Which means studying Jupiter teaches us how stars are born, how planets form, how solar systems evolve. Jupiter is a fossil, a frozen moment from the early days of our cosmic neighborhood, and its gravity has been shaping our solar system for 4.5 billion years. Steering asteroids, catching comets, possibly delivering water to Earth in the early days, possibly protecting us from impacts that would have ended life here. We owe Jupiter a lot. To get a sense of scale, if Earth were a grape, Jupiter would be a basketball. About 1,300 Earths could fit inside it. And it spins fast. A day on Jupiter is about 10 hours long. The whole planet rotates in less time than you spend at school. But let's go back into the clouds, because the closer you look, the more terrifying it gets. The great red spot, you've probably seen it in pictures. That big swirling oval. It's a hurricane wider than Earth, with winds up to 400 miles per hour. That has been raging continuously since at least 1831. Almost 200 years, possibly longer. We just started watching it then. It's been there the whole time, the lightning. I mentioned the green color, that's not artistic license, it's real. Confirmed by NASA's Juno spacecraft. Jupiter's lightning forms in clouds containing ammonia and water, and ammonia burns with a yellow-green flame. So when the bolts fire, they glow green, and they're powerful. About 100 times more powerful than lightning on Earth, mostly near the poles, the hailstones, or as scientists actually call them, mushballs. Slushy hailstones the size of softballs made of water and ammonia in roughly a 3-to-1 ratio. The ammonia acts like antifreeze, keeping the water from freezing solid at altitude. Violent updrafts toss them more than 60 kilometers above the cloud tops, and then they crash back down. There are storms on Jupiter where the precipitation is softball-sized chunks of slushy poison. And then, surrounding the entire planet, there's the radiation, belts of charged particles trapped by Jupiter's enormous magnetic field. They would kill an unshielded human in minutes. They fry electronics. Every probe we send needs massive shielding. This is why no one is ever going to park a space station here. We can't go. Not now, maybe, not ever. But here's what I keep coming back to. We grew up on science fiction, and science fiction lied to us. Every alien planet in every movie looks like Earth. Forests, oceans, blue skies. Maybe a couple of moons, aliens that look like people with weird foreheads. Look at our actual solar system, Jupiter, clouds of ammonia, hailstones of slush, lightning, that's the wrong color, alien. Europa, Jupiter's moon, a frozen ball with an ocean underneath the ice. An ocean that probably contains more liquid water than every ocean on Earth combined. Alien, Titan, Saturn's moon, where it actually rains liquid methane, where there are lakes of liquid methane. A whole hydrological cycle, but with methane instead of water. Alien. These aren't theoretical exoplanets light years away, they're our neighbors. And here's where it gets speculative. I want to be clear, this is speculation, not established science. But it's grounded speculation. In 1976, the astronomer Carl Sagan and physicist Edwin Salpeter wrote a paper imagining life in Jupiter's atmosphere. Not as a serious prediction, as a thought experiment. They proposed creatures they called floaters, huge gas-filled organisms drifting in the clouds, like atmospheric jellyfish, and sinkers, predators that hunt the floaters. Could it be real? We don't know. Probably not, given what we now understand about the chemistry. But the deeper point holds. What if something out there metabolizes ammonia instead of oxygen? What if life adapted to pressure that crushes our machines? What if life doesn't need water or sunlight or warmth? The universe doesn't have to look like Earth, and it probably doesn't. So what's next? Humans almost certainly aren't going to descend into Jupiter. There's nowhere to land. The radiation alone would kill us, and the trip itself takes years, but the moons, that's the real frontier. Europa Clipper launched in October 2024. It arrives in April 2030. It's going to make 49 close flybys of Europa, looking for signs of habitability under that ice. The European Space Agency's JUICE mission is also out there studying Ganymede, Callisto, and Europa. Think about this. We sent a probe to Jupiter in 1995 with technology designed in the 1980s, and it survived an hour falling through hell. Imagine what we'll send in 2070. Imagine what we'll find. Maybe humans never walk in Jupiter's clouds, but our machines are going to keep going. Jupiter is closer than the nearest star. You can see it tonight with your naked eye, from your backyard. And it is completely, utterly alien. The clouds, the storms, the lightning, the moons, none of it looks like home. None of it has to. We are not alone in being weird. The universe is stranger than we imagine. And it's right there. Always has been. This is Nerd Voyager. Next stop somewhere even weirder.